Suppose S is a non-empty subset of R. Which of the following is necessarily true? For each S and T in S, there exists a continuous function f mapping 0, 1 into S, with f of 0 equals S and f of 1 equals T. So that's not true, because if S is not connected, or not path connected, the function f would need to be discontinuous somewhere. It might have to jump over gaps in S, basically. So A is not the correct answer. B. Let me draw out a picture of exactly what I mean here. So like here's the real number line. So here's the number line. Suppose that S is, that subset of the number line. And if this is S and this is T, then there's no continuous function that maps the interval 0, 1 into S with f of 0 equals S and f of 1 equals T. Because if we're continuous, you'd have to jump over some gap. So it can't be option A. Let's think about option B. For each U not in S, there exists an open subset U of R such that U is in U and U intersect S is empty. So that's also false. If suppose the set S is everything except for one point. So let's say that even is 0. Suppose 0 is the only element in R that is not in S. Then if this is the point U, any open set around U will intersect S. So B is false. Let's look at option C. Okay, so we have a definition of a set here. It's the set of all points in S such that there exists an open subset V of R with okay, so it's the set of all points such that there's an open set around V which is contained in S. I believe that's true, actually, but let's come back to so like it's the set of all interior points, right? I believe that's just the definition of the interior of S, which is I mean the interior of S is an open subset, but I'm going to come back to that. So D. So we have a set, the set of all points not in S, such that there exists an open subset W with W and W intersect S is empty. So this is a closed subset of R. Okay, I'll have to come back to that one as well, figure out which one of these two is the right one. And E, S is the intersection of all closed subsets of R that contain S. So that one's definitely false, because if S itself is if S itself is an open interval, then the intersection of all closed subsets of R that contain S could have more points. So I mean, let me just trace out E. Again, there's the real numbers. If S is an interval like this, then the intersection of all subsets of R that contain S, that will end up containing the endpoints here. So E is false. So between C and D, I'm still pretty sure that the answer here is C, because I'm fairly certain that's just the definition of the interior of S. But so let's draw, for example, let's draw like a half closed interval like that and see where things break down. And I think there's going to be a breakdown over here on this point. So or maybe the breakdown will be there. Okay. So we're looking at all the points. If I want to construct this set, the subset which is being described here, W which are not in S, there exists W open and W intersect S is equal to null is closed. Okay, so every single point out here and out here is in this set. It's only the endpoints of these intervals which are questionable. So the endpoint of this interval will not be in this set. So because any open interval there, any open set around that point intersects S. So let me draw in another color what this set looks like. It's going to be everything here and everything here, but it will not contain either of the endpoints, in fact. It does not contain that endpoint. And does not so I mean, you draw it with open interval notation like that. So not only is it closed, but in this example it's open. So D is false, and the answer is C. Yeah. If I were if I were more freshly studied in basic topology stuff, I'm sure this one would have been immediate. I mean, it almost was, right? Like I looked at option C and recognized it as the definition of the interior, or at least I'm pretty sure it was. And option D, while it looks suspiciously like it might be true, a little thought with a simple example shows that it's not a true statement. Yeah, this one should have gone a little bit quicker. But again, if you're freshly studied in this kind of stuff, then this question, I'm sure, would be almost immediate. Thanks for watching.